Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Welcome to GOTO Unscripted. We are here in the beautiful city of Chicago. It is not raining. It is certainly not really even windy today. Beautiful weather for GOTO Chicago in October, so happy to be here. Another episode of GOTO Unscripted, talking to other speakers who are here at GOTO. Brooklyn Zelenka, welcome to GOTO. Have you been to Chicago before?
Once, briefly, in 2019.
This is my first time, and I'm loving it. So if I come back, I'm asking the Chicagoans, please can you put the good weather on again, because then it's so much better. And yeah, no ice or frozen, that's all I think about Chicago. You're a distributed systems researcher. That can be a broad title. What does that mean for what you're researching?
Yeah. So I've worked in a bunch of different areas. My career has really evolved over time into working on primarily access control, but also distributed computing, so getting multiple machines to coordinate on a problem or divide up a problem across things that may or may not even be co-located. So the two main projects that I've worked on in the past few years are essentially across identity, data, and compute. Sounds pretty broad, but making sure that data, no matter where it lives, and no matter how many replicas there are, can always be stitched back together after. That everywhere it lives is access controlled, so it's encrypted or otherwise managed without a central server. And compute so that no matter, even if you're on a plane or no matter what you're doing, you can still run computation even if you're disconnected from, say, a data center. Okay,
so the distributed computing problem that it's solving, is that one of scale because you need to separate the problem into n number of things to iterate individually on that? Why wouldn't you just run it on one system, or a system can't be big enough to run all of that?
Yeah, so there's a few reasons. One is latency. So if you have really small jobs, so we're not talking, if you have, you're training an LLM, latency isn't the bottleneck there, yeah. Right? A couple hundred milliseconds, whatever. But if you have something that's more like functions as a service or a Lambda, something like this, if you can save yourself a couple hundred milliseconds by computing completely locally or on a computer sitting right next to you, rather than always going out to US East, you've saved yourself all of that round trip time. And so you can make it much, much faster. And additionally, if you're, say, working on a train and you go through a tunnel and you lose connection, it really sucks to have to restart that job or, hope that it finishes or any of these things. So a lot of my work centers around making sure that things that can be computed locally are computed locally. And when you absolutely need to go to some external service, so let's say, sending an email, that can either be put off as long as possible until you're reconnected, or if it's actually required, that it's not, the application developer having to juggle all of these concerns, that it can sort of alert you to that early rather than having to build all of that context yourself.
Okay, so instead of writing something all locally, now you've got to go and use a cloud service or a database remotely or some kind of thing, and you're not ready for it at that moment in time, and your sort of local computation breaks down.
Yeah, so one way of thinking about, it's a very different model from how people build software today. Right. So we've been essentially building software the same way for 30 years. And it used to be that you had a beige box that lived under your desk and you would turn it on and off and you would dial over the internet and tie up your phone line, all these things.
I'm old enough to remember.
And so if you wanted something like to host your photos or email, you would have to rent a server from somebody that was online all the time. Right? And then you end up with all these concerns about scale and, if you're disconnected, they're still around for you, but then, they have to secure it separately. So you have to really trust them, all of these things. And you do deal with that latency in addition. And in the intervening years, we've tried to extend that metaphor by saying, well, we need to get more scale. So we're going to containerize things and we'll scale them up and down and try to hide all of that complexity. And now you have this very clear distinctions between front-end engineers, back-end engineers, DevOps, people that specialize in things like Kubernetes, which is quite a complex tool. And some of us have taken a step back and said, well, what if we re-architected software in a way where there isn't a required central server that has to deal with all this scale? All of our devices are quite powerful now, right? Like my phone is incredibly powerful. Why can't I do most of that computation locally and only go to the cloud when I absolutely have to? It'll feel much faster because I'm not paying for that latency. And I don't have to necessarily rely on somebody else to run all that infrastructure for me. So Google famously kills applications all the time. There's a website, the count is, I think, 295 apps killed, in the past few years. If all of your software runs completely locally, nobody can shut it down. Nobody has to pay for that infrastructure cost. The economics become very, very different. The dividing line, though, and I keep saying when you don't have to go out to the cloud, is sometimes you actually need coordination. We have very good understanding at this point in about the last 10 years of which things can be done without requiring a central server and which things require it. And so a lot of my work has come down to making that division hidden from developers so that it just happens automatically.
But it seems like one of the problems that you can solve is when you're writing your own application and everything is all together, because you can potentially run a lot of that yourself. How do you think about the interactions with other companies or other microservices or other anything else where that coordination is across a much bigger domain boundary than possibly you can do everything locally, or maybe you can do everything locally?
So it does take a lot of the things that today you'd have to go out to a bunch of different services and bring them local, right? Because so much of that is about infrastructure and scale today. But absolutely, there are some things where you don't own the entire stack. So if you want to send a text message, you're probably going to use a text messaging SMS service, right? And so these are the kinds of things where we have to know what can be computed locally and what is required to be done remotely. And so if you have a remote service that you rely on, so let's say it's the Blue Sky fire hose, right? Just like all the stuff coming off of Blue Sky. You probably don't have all of that locally, right? Other people are making edits and stuff, and it's a scale that your local device probably won't handle, right?
Yeah.
Going to some server that's indexing all of that for you is completely reasonable. And so a lot of this becomes then, well, that's something that requires coordination, or at least to go to an external service. And we can mark that as this is something that I'm relying on somebody else for. And if I've made that request, in the past, however long, couple of minutes, maybe I can and I'm offline now, maybe I can reuse the automatically cached version until that cache expires. And we don't want to have individual developers having to think about all of these concerns. What if we can just automate that away for them? So that, if you're building an app, step one, let's say you're building a Node app, right? Step one, you build the application locally, you have some dummy data, you have a dummy database, and the whole thing's working, and maybe you call out to some dummy external APIs. Step one now is you have to containerize it, find a host, get that all set up and in the cloud somewhere. And then it really quickly turns into, well, I may as well use their database and all of these parts. What if we could just ship our mock version of the application instead? And we know already where those boundaries are of, okay, I need to talk to this external service and that external service. If we can build an application model or a RPC model inside of that goes, oh, I made this call and I received something back, and I can register that now into my application as if it was just regular normal data, then it can treat that as if it's something now, after it's gotten that request back, as something that it owns. So it's only ever learning about data from the outside world and communicating with the outside world infrequently compared to always having to go over the internet.
So you're talking about how sort of software architecture has been the same for about 20 or 30 years. Mm-hmm. What fundamentally does change for this new approach? Because it seems to be that if I was to use current architectural practices, it is going to be a whole bunch of containers because I need to set up whatever kind of infrastructure, or even if it's just a normal programming parlance. But these could be huge. There's a whole amount of code that you need to do. Mm-hmm. People solve that with containerization, or have huge monoliths that run on their laptop. Mm-hmm. It seems as though you're saying that there's a simpler approach to do that doesn't involve installing a whole bunch of crazy stuff. How does that actually work then?
Yeah.
Or what do you install, or how do you get started?
Yeah. So for the developer, for the consumer, like
either,
end user,
yeah.
Either. Okay. So I'll start by answering it from like what ends up being the end user experience. Assuming that we do everything correctly, it should be completely invisible to the end user, that anything special is happening.
So when you say end user, just to clarify as well, is that I'm building an application and an end user may be, somebody walking down the street in a mobile phone accessing my website, for example?
Exactly, yeah. So in that case, we still need to serve them the website.
Yeah.
But typically in this model, local first, that website is just static, right? So we can cache that very, very well. It doesn't require on any state or databases, any of this stuff, right? It's often a single page application, doesn't have to be, but think more SPA world. So they load that up. It sets everything up it needs. It creates some key pairs locally, maybe uses the Web Crypto API, maybe uses passkeys, all of this stuff. And it creates for itself a local database. And the user just starts using it. So maybe it's a text editing application, collaborative text editing, right? So like a Google Docs clone. So they're typing away and they invite their friend, and their friend starts typing as well. And they're going through, maybe even a relay server at this point. And then they get onto a plane and they don't have access to that server anymore. They can connect over Bluetooth and continue editing because there isn't a single copy of a database somewhere that is the single source of truth. We gain massive scale by simplifying each individual node to say, well, I don't have to worry about everyone in the world and keeping them separate from each other and, tenancy and all of this stuff. If you have access to the data, you have access to the data. You should be able to edit it. And if every replica, every device is its own source of truth, and we don't expect everyone to have exactly the same data at all times, then, you and I can get on a plane, edit, and when we get off the plane, we use essentially fancy data structures that know how to automatically stitch that together. Think about it almost like a Git without having to do manual merges.
Okay.
A lot of, large-scale databases use similar techniques to achieve high scale in a cluster. And we're saying, well, what if we took that instead of to like a point of presence edge, what if we took that to the far edge, to every individual device? And of course, this doesn't work if you need really strong consistency. So there's a researcher, May Milano, who does really fantastic stuff, who's explored this idea of, essentially flexible consistency. So if I have a video game platform, the only one who really cares about the current state of that game, if we're playing, is the two of us. We don't have to have everybody else in the world know about it. But if we're going to rank, this is an example she gives, at least, if we're going to rank the top 10 players in the world, we'd better all agree who the top 10 players in the world really are. And that probably then requires some central, at least coordination, to know, here's everybody's actual rankings. So there is this boundary, basically, that says, if we're just doing text editing amongst friends, this is totally fine. And we don't require a server because we can use CRDTs, these fancy data structures that stitch together, to get everybody back in sync once they hear about each other. But again, think of it more like Git rather than how you think of a traditional database, which is a single source of truth. Yeah. Git, you're always branching and merging. And this knows how to do the branches and merges automatically.
Okay. So that was from then the consumer of your website, for example. So in a way, your mobile phone would have a local instance of a database that has able to synchronize offline these fancy data structures and do the clever merging. In terms of developing the application, that was the second part. How does that work?
Yeah, so typically use some toolkits. So just like how you use a web framework, you would use something for those three layers again, auth, data, compute. So the team that I work with right now, Ink and Switch, have a project called AutoMerge, which is one of these fancy data structures. And it gives you what looks like essentially a JSON API, where you have a document, which is just a JSON structure. You wrap it in a call to, automerge.change, and then you get a variable, and then you do all of your normal things. I want to change this field, so I have, doc.myField equals whatever, hello world. And at the end, that will create all of the bookkeeping under the hood required to make this automatically mergeable, auto merge. So you'd use a toolkit like AutoMerge or my project, which is adding access control to it, Beehive. And they just give you nice top-level APIs in the same way that Node or Rails or any of these other things give you, which is invite member, edit documents, create a bunch of different documents, pointing at a particular sync server if you want a sync server. And so, even when trying to demo this stuff with people live, it's often a little bit anticlimactic because it's like, it does all this cool stuff under the hood. And then you get there and you're like, so I'm editing JSON? I'm like, yeah, you're editing JSON.
That's what percentage of computer science is just editing JSON behind the scenes?
Know, right?
So you installing a framework that allows you to have this sort of opinionated process, editing JSON and then communication. You don't need to use the cloud. Sometimes you need to use the cloud. Where does it get hosted? If it's just sitting on my laptop, but I've got somebody walking down the street connecting to it, what's the sort of communication mechanism or networking mechanism that makes this collaboration possible?
Yeah. I'll give you first the non-answer and then the practical answer. The non-answer is that this system doesn't care how the bytes move around. As long as it can receive messages, like you could literally load them onto a USB stick and move them across, and that would continue to work. In practice, people have tried two main approaches. One is peer-to-peer. Peer-to-peer tech is hard, especially behind things like consumer Wi-Fi, NAT traversal. The one that always works is to still put a server in the middle. We call these sync servers.
Okay.
The idea is that unlike deploying an application where in a database, and the database has to know your entire schema and all of this extra information, sync servers are pretty dumb, and all they know is, I received some bytes. Those bytes belong to this label, and somebody else requests those. Am I allowed to send them to them? Yes. Okay, cool. Here's those bytes. And then all of the interpretation of that happens on the client. So they can be deployed everywhere. They can be inside of a serverless function. They can be run as a standalone server. A single standalone server could run this for many applications without knowing anything about the data on the inside. You can scale them out. You can use several. They're very, very lightweight. They're really just a relay.
Okay.
Yeah.
So in a way, these sync servers are just the sort of traffic cops that, traffic is coming in, car comes along the road, probably bad analogy, and sends it down that route or sends it down that route. And that does it. I mean, what about things like broadcasting? If you need to send the same message to many people, or many people need to communicate with many more people, does the complexity ramp up when that happens, or it's just more data?
It's just more data.
Okay.
So doing things like broadcast, you can either do everybody's pulling from the server. So the nice thing about this model is we can diverge for an unbounded amount of time, right? Again, the airplane example, I can be disconnected and continue working. And so it's more like, even in this broadcast world, I don't require that everybody notify me, we all got the same message, or like some quorum, all have received it already. It's, we send stuff and maybe they're online, maybe they're not. It's totally fine for me. And the sync server, if it wants to support, having an open, say, WebSocket channel where I can just push things out, right, automatically with subscriptions, then great. Then they're going to get them automatically. If they are offline and they come online and they just do a regular HTTP GET, it's also equivalent in the system. If you think about it from, in distributed systems, we spend a lot of time thinking about the speed of light. From the point of view of the speed of light, anytime you're talking through a sync server, you're at hundreds of milliseconds. This is glacial for the speed of light. So in a practical sense, if you're online, it'll feel snappy at human scales, seconds, milliseconds, hundreds of milliseconds, right? But there isn't really a distinction in the system between it took 100 milliseconds or it took 3 years. The underlying application doesn't really care. And
I suppose your interaction with the data is always local in a way for your local copy of the data. Yes. So is this in a way a sort of federated database? Maybe that's a way to think about it, that you don't have the central coordination database where you're doing reads and writes via an API. You have a data model that acts locally. The data model has some way it knows where it needs to send information, maybe around the sort of central server or directly via peer-to-peer. And then these data structures are just going to basically merge information that flows around. Is that a way to think about it?
It's a perfect way of thinking about it.
Okay. So I know, reading up on you, there's also additional information you've done and released where this maybe thinks about blockchains or that kind of technology, because obviously peer-to-peer networks and Ethereum or other kinds of things. How does that play into this?
So, many years ago, I'd worked on the Ethereum protocol itself, mostly around the virtual machine. Peer-to-peer, and we end up using a lot of similar techniques actually under the hood, hash linking, things like this. But the primary difference between the two is, in a blockchain, everyone in the world has to agree on the current state of the world, right? And so we're doing all of that coordination all of the time. The main difference is that there's no single owner.
So it's computationally expensive at scale because everyone has to agree.
Yeah, exactly. It's not even necessarily that the computation is expensive. It's all of the coordination of agreeing, right? That this is the latest version. And at least when I started on Local First, we said, well, what if we took all of those techniques and applied them to things where we didn't have to all agree on things? What if we went to the opposite side and said, well, there's no single owner, but we don't all have to agree in lockstep what's happening. And so we took a lot of those same techniques and moved them over into this world. They're on their own, they feel very, very different, right? If you're doing something on a blockchain, you get on an airplane, it's going to keep moving ahead without you. And you pay in performance and time for that consistency. Local First doesn't have those problems, but there's nothing saying that the two can't interact. And in fact, I've seen a few projects, like Anytype is one that uses both Local First between checkpoints on a blockchain, and then they actually checkpoint in mostly for access control in there. So the two actually can be compatible, but whenever you have a system that has weaker consistency, like Local First, and very strong consistency, like a blockchain, you always have to drop down to the strongest version. Yeah. So, between checkpoints, it can be very fast and fluid, but then if you're doing a checkpoint, you may, you made a bunch of edits offline, you may not be consistent with that checkpoint anymore, the previous checkpoint, if you didn't get your merge in. So the two can be compatible, but you give up a lot of the benefits of Local First as soon as you involve stronger consistency.
Okay. Another thing I was thinking of, Local First, sounds good, but what about sort of data protection? I lose my phone, I'm disconnected, there's no central storage state of something. Where's my stuff?
Yeah, absolutely. So this is the main thing that I'm working on right now at Ink & Switch. I'd worked on access control, Local First access control at my previous company, Fission. And until quite recently, maybe the last year, people didn't really care about this problem because they're mostly working on stuff for themselves or their friends. And now they're trying to do things for like real customers. And now it's, life or death, right? In traditional access control, you rely on there being a network boundary. So there's a resource server somewhere, and I can't read all of the data because it's over there. And there's a guard in front of it saying, you're allowed to read this, you're allowed to read that. In this world where everybody has the data and everybody's data is, equally, good, and we'll merge it back together later, all of these things, that model fundamentally breaks down. So there's two halves in the solution. One is read access queries, and mutation access, like to control changes to the document. Because maybe somebody starts, we have this collaborative text editing, and somebody starts defacing the document and writing all kinds of horrible things in there, and we want to say, kick them out. For read access, there's one main layer, which is we encrypt everything at rest. So any change, everybody has a copy of it encrypted, and only if they have the key can they decrypt it. All cryptography is eventually breakable. If you think about 50 years from now, maybe you don't want somebody getting into your document. So the extra layer we put on top of that is the sync servers will only give you the encrypted bytes if you're a member of the group.
Okay.
In addition. So it's this two-layer thing. If somebody breaks into the sync server, they can't read anything because it's all already encrypted. Sync server doesn't need to know how to read any of the documents because it doesn't need to do anything with it anyway. So it's all encrypted at rest. For mutations, for changes to the document, we have a list of who's allowed to, who's in the group, admins who can change that list. And any change applied to the document is then signed. And when you receive a change, you look, are they on the list? Do they match the signature? No? Cool. I can throw that one out. I don't have to worry about it.
So how does, if somebody's interested in this, what are the changes they need to do? Is it a different programming module? Obviously, it's a different framework to use, but what is the transition from the traditional way we've been building software now into this Local First mode?
Yeah. So the one asterisk I'll put on this is Local First is much, 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 much newer than things like containerization and Kubernetes and all of this stuff. But the stack is much smaller as well, because it's a rethinking of what do we actually want to do? Right? So the place I would say to start is go to automerge.org and start using automerge, get used to its APIs. And it really just feels like you're editing JSON in the browser. And you don't have to worry about all of these other things. You can use a sync server. So EcoSwitch runs one. There's a bunch of teams that are running them as well. And again, they don't have to know anything about your data. So they're essentially interoperable. And there's actually some work right now going into being able to host these things on like Dropbox or Google Drive, right? Without having to worry about setting up a specialized server. Today, there's specialized sync servers. Or you could host your own. So the only part that you have to actually interact with another team is how do I actually move the bytes around on the network? So which sync server do I want to use? Other than that, you just use auto merge or something similar. So there's Serenity, DXOS, there's a few, YJS, there's a few of these projects.
Okay. Yeah. I mean, Serenity is new. What are the sort of use cases or example applications? You've obviously talked about document sharing or document collaborative editing. What sort of else? If people are thinking, this sounds great, sounds interesting, I want to transition what I'm building over to this, what would be the use cases or things people would create?
Yeah, so I'll both tell you the things that it's good for and the things that it's not good for. So anything, I like to think of the distinction as big world versus small world. If you're building a shopping list for you and your friends, or, scale up into the thousands, really. If you're doing collaborative document editing or drawing application or anything like that, this is fantastic. You could build messaging apps.
So is there anything within a sort of either one-to-one or a smaller group collaborative?
Yeah,
function?
like some thousands. Yeah, exactly. When you start to need things like indexing, or you don't care about everybody else on that particular application, but you want to still be able to, get discovery. So you're building, say, a social network that's some millions of people, right? Yeah. Where you probably want to just cut down to a certain number and you want indexes so that you can search across the entire thing. You don't want to get all of that information all the time. You want somebody else to build an index for you. That's big world. Yeah. And so it's not as good for ingesting the Twitter fire hose, right? Or Blue Sky fire hose these days. So for things that are, sometimes we say related to the cozy web, things like this.
The cozy web, I like that.
Yeah, right? Where, maybe it's inside of a single organization or across a couple organizations, as opposed to everyone in the world tweeting all the time. It's really great for those.
In fact, just thinking about we shouldn't have social networking. We should have cozy networking.
We should.
Be much better.
Yes.
There we go. I like it.
Well, and there's some thinking in the space, not my work, other people's work, talking about how because this is such a smaller stack to learn, that it really lowers the barrier to entry, gets more people involved, and you only need quote unquote front-end skills to do this. And so you could build apps. There's a great article, an app can be a home-cooked meal, literally just for you and your friends. It doesn't have to be at massive scale where you're going to charge people a subscription. It can go down to one or two people or, up to thousands. When you start getting to the millions, then you probably want indexes.
Then that's it. I mean, you're a distributed computing researcher, so the whole thing is as things get bigger, they get more distributed, and the complexity does creep in as well. Yeah. So, I mean, so it's front end focused. You mentioned WebSockets beforehand. So the mental image is, writing in your front end code, sort of WebSockets for some of the communication. I know that's not going to be across the whole stack, but maybe to your the syncing server and a local database that's going to magically auto merge the sync kind of things. Is that sort of a mental model of a front end engineer with the tools that they can sort of put together and get going?
Yeah, exactly.
Okay. Yeah. So what else haven't we spoken about today that is of interest and you think are burning with excitement that people should be knowing about?
Well, I spend most of my time these days on those three layers I mentioned before: auth, data, and compute. Yeah. Data is the most mature in the stack. Auth, there are existing auth solutions in the space like UCAN and another auth project that I've worked on for some time, and Beehive, my current research project inside of Encryption. And then there are also distributed compute, like local first compute networks. Like the one I work on is called IPVM, Interplanetary Virtual Machine, which is the least mature in that stack.
In an interplanetary virtual machine, that seems like the complete antithesis of a local first thing if it's in a virtual machine, or how are they connected?
So it's WASM under the hood.
Okay.
And the basic idea is it should scale up as much as it needs automatically without having to worry about it.
So that virtual machine you're speaking about is the local experience, but just can be scaled out to wherever based on a WASM thing.
Yes, exactly. Okay. So anything that you can run locally can still run locally, but maybe you're on, say, a low-powered phone, and it's going to take some minutes to process something. If you're connected to the internet, you should be able to take that WebAssembly and the data move it somewhere else, compute on it, and send you the result back.
Yeah.
But if you're offline, you can wait for it to finish too. So you're rendering a 3D scene or something.
So in a way, solving the portability of applications which we've used with containers,
yes.
You're in fact micro-container it by using WASM as a sort of binary kind of format with your additional data and your JSON structure. And because it's much smaller, you could move things interplanetary and do compute wherever it maybe needs to be, or move things anywhere.
Yes, exactly. And we can then also take, if you're computing over very large amounts of data, you can take your WebAssembly, push the compute to the data, have it run, and send you the result back. And most of the challenges there is around verifiability of the result.
Which is part of your auth.
Yes. Yeah, it's very closely related, yeah.
Excellent. Well, this sounds sort of super interesting. You mentioned a few links. Where should people go to find more information, and where can people start exploring?
Yeah, so there's a podcast, localfirst.fm. I'm actually going to be doing a podcast with them in a couple weeks. There's the Ink and Switch Discord, and so the AutoMerge Discord. So if you go to automerge.org, it has links to all of these things there. And there's also a Local First Discord as well.
Excellent. Yeah. Thank you very much.
Great.
Thanks so much for joining us here on GOTO Unscripted in lovely Chicago, where we're speaking to other speakers here at the GOTO conference and finding cool new things for distributed computing. I appreciate your time. Thank you very much.
Thank you.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.